Hey guys, welcome to 4.4b, which is factoring polynomials by grouping. So basically this is just a new technique for factoring. Let's go ahead and do a little bit of review just to remind ourselves. So review of 4.4a, this is where we were practicing the regular factoring of like quadratics. So this problem we would do the double parenthesis, x squared minus 3x minus 4, we would get x and x. Factors of 4 that have a difference of 3 would be 4 and 1, and then we know the signs are different and the negative has to be the bigger one, so it's x minus 4 and x plus 1. Then over here, 3x squared minus 12, this one right away you got to notice there's only two terms, but each of them have a 3 in common, so we can factor out a 3 from both. We get x squared minus 4, and then remember x squared minus 4 is a difference of squares, so we can separate that out as x plus 2 and x minus 2. So this would be the most factored form for that one. And then this one's kind of a combination. Look at all the terms, look for the GCF first, and we notice we can take out a 3. We get x squared minus 2x plus 1. And we can factor that down again to two sets of parentheses. So signs are the same, x and x. The signs are both negative, okay? So we get minus, minus. So factors of 1 that combine to make 2 are going to be 1 and 1. So we could leave our answer like this, or we could write it as 3 times x minus 1 squared. Either one would work. Now, none of that is really new to Unit 4. We did those back in Unit 1, or Unit 3, excuse me. This technique, however, is new. Now notice when it says factoring by grouping, what we're going to do is we're going to group terms into parentheses in a different way. What we do to start this problem is notice that it starts with an x cubed, then x squared, then x, and then a constant. We always have to have it in this order, so it has to be in standard form. If you look at the first two terms, we're going to ignore negative 4x and negative 8 for a second. Just look at those terms and see what they have in common. What is their greatest common factor? Now, they both have a 9 that we can take out. 9 goes into 9 and 18. And we can also take out an x squared from both of them. Now, if I were to take 9x squared out of the first term, we're left with just a single x. Then we're going to do that to 18x squared, and we're going to be left with plus 2. Now we're going to ignore the first two terms, and we're just going to look at the negative 4x and the negative 8. What can you take out of both of those terms? Well, you can take out a negative 4. And then we're left with x, and remember, negative 8 divided by negative 4 would be plus 2. Now if you look at the parentheses that we have here, these are the exact same thing. So what we're going to do is we are going to take the front terms, the negative x squared minus 4, we're going to put those in their own parenthesis, 9x squared minus 4, and then the other parenthesis we're just going to put side by side is the x plus 2. What we did is technically this is one term now, this is another term, and we factored out x plus 2 from both of those terms, as odd as that might sound. But this is what our answer would be. Actually, we can take this one step further because this right here is factorable. So what we would get, we'd actually have 3 sets of parentheses. This is going to become 3x plus 2 and 3x minus 2 because that's a difference of squares. And then the x plus 2 can't factor anything there. So this is actually the complete answer. All right, let's try a couple more of these. The first one here, again, just look at the first two terms. What can you take out of both of those? We can always take we can take a 3 out. And then if you'll notice, we can always take an x squared out of these. You're going to see that as a common idea. Okay, and then we're left with x minus 4 is what we would have after factoring that out. Over here, we can take a positive 2 out, and we're left with x minus 4 again. If we're doing it correctly, you should get the same thing in parentheses. So now we're going to pick out the front pieces, put those in their own parenthesis, 3x squared plus 2, and then we have x minus 4 following right behind it. Notice though, this is actually the final answer. We can't factor either of these any further. This is where we have to stop with this problem. Okay, let's go ahead and do this next one. X cubed minus 5x squared. Look at those terms first. We can take out an x squared, and we're left with x minus 5. Now we look at the negative 9x and the positive 45. Well, we know that on the other side, we need to get the parenthesis to be x minus 5. So the only way to do that is to factor out a negative 9, which goes into both terms. And then we get x minus 5. Now what we're going to do, combine the front pieces, x squared minus 9, and then we have x minus 5 is the parenthesis they have in common. X squared minus 9 though, make sure you can recognize that. That's a difference of squares. That's an x plus 3 and an x minus 3, and then we have the x minus 5 at the end. Okay. All right, I'm going to let you guys try this example 3. These are very similar to what we were just doing. Make sure that you factor as far as possible. Be looking for differences of squares if those pop up.